Hi, welcome to SS 6.2, Perimeter, Area, and Volume. So our first task is just basically remembering what those three words mean. We have perimeter, we have area, we have volume. Okay, perimeter is 1D, one dimension. It is length, and that is it. Like the length of a fence. You would unroll all that fence wire and see how long it is. Area is 2D. Okay, I'm going to draw it over here. It has a length and it also has a width. Okay, and then volume, I think I circled the wrong word there. Volume is 3D. It has a length and a width and a depth. Does that make sense? So perimeter is one-dimensional, area is two-dimensional, and volume is 3D. So comparing them, analyzing the effect of orientation, if I take this block and turn it on its side, hey, guess what? It's still the same shape. It is still the same size. So orientation means absolutely nothing. Whichever way you point it, whichever way you turn it, it doesn't change the amount of area, perimeter, or volume. If I have a fence and it is shaped like this, and I tear down that fence and I use the same exact material to make my shape like this, it would be exactly the same. Okay, so changing the shape of your perimeter doesn't necessarily affect the size. All right, explain using models the relationship between the area of the base and the volume. So we've got some examples coming up with that. Problems involving perimeter and area and volume. And then we have a little slide at the end to critique these two statements and see if they are correct or not. Let's find out. Okay, very simply, the definitions for these three guys. Perimeter is a fence. Okay, so if you're trying to keep the evil purple bunny inside the fence, you would need to reinforce the perimeter. Keep your rabbit contained. Perimeter is one dimension. It is just length. That's it. And the formula for perimeter is, to find the perimeter, all you need to do is add up all the sides. So if you have a three-sided shape, a triangle, you would be adding three sides. If your fence holding your bunny rabbit in is four sides, you would add up all the sides. And that is it. Area, on the other hand, this here is an area rug. That is actually what they're called, area rug. So remember the rug. Okay, it's 2D. It has length and it has width. Okay, and that's actually the formula right there, is L times W, length times the width, because we want to know how many units long is it and how many units wide is it, and then just imagine that we've counted out all those squares and counted them all up, and that would give our total square footage. So area is always measured in units with a little 2 up there, units squared. So it might be centimeters squared, it might be meters squared, it might be kilometers squared. It's always the distance, but not just a straight distance, it's a square distance. Down at the bottom, volume is how much can something hold? So I have a picture of a shipping container there. How much does it hold? Did you know you can make a swimming pool out of a shipping container? I think we should try that. I think that'd be a really cool class project. Swimming pool in the classroom. Because, you know, it's volume. The children need to learn. So volume is a 3D deal. And you can tell in my diagram here, this shipping container has a length, it has a width, and it also has a height. Okay? Length times width times height. You take those three measurements, multiply them together, presto, you have a swimming pool. And volume is measured in cubic units, so you would use a little 3 because the 3 tells us that there are 3 dimensions. The 2 tells us that there are 2 dimensions. Perimeter is just straight old meters or centimeters. There is no number up there. There is nothing there because it's not a cubic unit, it's just a linear, liney measurement of length. Okay. So let's do a little work with perimeter. Remember, perimeter is just 1D. It is simply the length of your fence. Okay. Formula for perimeter. This is what I really want to see you guys doing is when you start with any perimeter area or volume unit or question, I want you to start with your recipe. Nice and neat. That is step number 1. So P equals add all sides. Now we can stay organized and we know what we're doing. And so as you drop down, your next step is to say P, same, just drop it straight down, right? Keep your equal sign, keep it straight down. And then instead of writing add all sides, we're going to put in the numbers. What are the measurements? Well, let's pretend that this here fence, I should draw something for you. This fence is going to contain a ginormous earthworm with yellow eyes. Yes, I think that'll do nicely. Okay, so our fence, let's say this side is 20 meters. Let's say this side is 30 meters, and it is a rectangle. It's 20 by 30. So if we're going to add up all the sides, I need one that's 20. I need that one that's 30. Now, are 2 sides enough to keep my earthworm contained? No, they are not. I need 4 sides. So you know that the other 4 sides or the other 2 sides are exactly the same because I said it was a rectangle. 20 plus 30 plus 20 plus 30. Okay, next step, we drop down again, straight down. We keep that P lined up. We keep our equal sign all lined up. You don't need to put arrows in like I just did, but I do want you to look at that. I can use the white as an eraser. Oh, I just figured that out. I'm like 50 videos in. Learn something new every day. Okay. So now we need to add up our 20 plus 30 plus 20 plus 30. Have you got it? "100 meters." And we always need to put our units, that meters, right? And in the case of perimeter, since it's just a linear measurement, it's just 1D, we don't need any squared or cubic units or anything like that. Just plain old meters, found the length of our fence, and we are good to go. And my worm is happy. Yes, like with lipstick, he looks good. All right, next is area. And again, area is the rug. Area is 2D. It has a width and it has a length. Okay, so again, we start with our recipe. A equals L times W. That should be at the front of every area question you ever do. Now this formula, this L times W, is only for squares and rectangles. Okay, if you have a triangle or some other shape, this formula is not going to work. But for today's lesson, we're just going to use length times width. We drop down our A. Let's say that our carpet is 1, 2, 3, 4, 5, 6 units long and 1, 2, 3, 4 units wide. Okay, we drop down our A, we drop down our equal sign. 6 times 4 is 24. And this time we need, oh, what did I have? Rugs are usually feet. So we'll put our answer in feet today. And because it is two-dimensional, we need this little 2 to say 24 feet squared. Because if I went to the carpet store and I said, hey, I need 24 feet of carpet, they could roll out 24 feet of carpet 1 inch wide. Or they could roll out 24 feet of carpet 24 feet wide. And then I would have a ton of carpet. So it's important that you say what your square footage is for area. Area equals 24 square feet, or feet squared. If it was meters, you would say meters squared. If it was centimeters, centimeters squared. Area is 2D, so you need the little 2. Volume. Sorry, this is not a swimming pool. This is a really exciting block. Let's start with our recipe. V equals 3D, remember? L times W times height. And it says it's 3 blocks high, it's 5 blocks wide, and it's 4 blocks deep. Now they didn't call it length, they called it depth, which same thing, right? We could say that this here is the length. It doesn't matter. Multiplication is commutative, so it doesn't matter what order you put them in, you can have any old number. So I'm just going to pop those numbers right in. I don't even care what they're called. We have a 3, we have a 5, we have a 4. Okay? And then we drop down again, our V. 5 times 4 is 20, times 3 is 60. And since they've called these things blocks, I'm going to say blocks and give it the little 3. Make sure you have the 3 on there because volume is 3D. It has 3 dimensions. So 60 blocks cubed because this thing is like a cube. Okay, let's critique these statements. For any 2 right rectangular prisms, so think about a Kleenex box. Okay, and let's draw another one. It's going to be a board game box, so it's not very high. Okay, so these are both 3D, right? And this first statement is saying the one that has the greater volume is going to be the one that has the greatest base area. So let's find out if that's true. Let's say that my base area, I don't know, 1, 2, 3, 4 times 1, 2, 3, 4, 5, and 1, 2, 3. Okay, so volume equals 5 times 4 times 3, and that would give us 5 times 4 is 20, times 3 is 60. And then the area on this is just length times width. And they just want to know what the area of the base is, what it's sitting on. Okay, and that is a 4 by 3 base. Okay, so our area equals 12. And we're going to say these are meters. So 12 meters squared and 60 cubic meters. Good to go so far? Let's do the green one. So I'll just count out some random numbers here. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then the height is going to be 1. Okay, so volume, 1 times 3 times 15. I guess I should have put in my recipe. Base times height times, oops, sorry. Let's not, oopsies. Let's call that, look at that, I used white twice in one video. Length times height times width. Sure. And for our area, just length times width. Okay, back to our green guy. Volume, 1 times 3 is 3, 3 times 15. Think about time. Here's a clock. There's 15, 30, 45, and 60, right? So 15 times 3, 45. And that is cubic meters. And then our area for that particular shape, we are just talking about the base. So 3 times 15 would be that bottom area of the base, what is sitting on the countertop. So 3 times 15, which is also 45, and it's just meters squared. So now the statement says that whoever has the most surface area touching the ground is going to have the biggest volume. Well, this box had 12 meters touching the ground. Its area rug on the bottom of this shape was 12 meters. This one, its area rug was 45 meters, right? There's quite a difference in the area. So the board game box has a much bigger area. Okay, it's going to take up more of your carpet. However, if we were going to fill up both containers with milk all the way to the top, this would need 60 cubic meters of milk, and the board game would only need 45. That's a really big board game, by the way. 45 meters cubed. Whew, barely fit in the house. It's like Jumanji. So what we have found here is that even though this Kleenex box had a much smaller area, it ended up having a much bigger volume. So statement number 1 is not correct, because remember we said it doesn't matter how you turn that box. We can turn the Kleenex box on its side, we can tip it up on its end, right? It's the same shape. It doesn't matter what is touching on the bottom area. Okay, let's try the next one. For any two rectangles, the rectangle with the greatest perimeter will also have the greatest area. Here's a rectangle. And here is a rectangle. So we're going to say this one is 1, 1, 1, and 1, and this one is 10 and 4. Okay, so perimeter is add all sides, and area is length times width. So let's pop those in and see what we got. If I add it up, oops, 4 plus 10 plus 4. Over here we have perimeter equals 1 plus 1 plus 1 plus 1 plus 1. Do we have 4 there? 1, 2, 3, 4. One too many. Let's take out this messy one. So great. Okay, 1 plus 1 plus 1 plus 1. There's our 4 sides, so we know the perimeter on that one is 4, and we know the perimeter on the big one is 14 plus 14, which is 28. And we'll call these centimeters. Okay, now for area. Oops, need a new color. On the big shape, 10 times 4, which would give us 40 centimeters squared. And on the little shape, 1 times 1, oh, that's supposed to be an A, sorry. 1. 1 whole centimeter squared is what that guy is taking up. So in this case, this one had the greatest perimeter, and it also has the greatest area. Seems to make sense, but let's try another example. Nice straight line I got going on. Let's say this is 1 and this is 20. Perimeter is add all sides. 1 plus 20 plus 1 plus 20. Make sense? Added them all up, I got 42. The area of that same shape, length times width, 1 times 20, is 20 centimeters squared. Good to go? So for any two rectangles, the rectangle with the greatest perimeter, so if I increase the perimeter, it's going to increase the area. Okay, so let's change my perimeter and let's make it 4 and 5. Okay, so perimeter equals 4 plus 5 plus 4 plus 5, and that adds up to 18. The area of that same shape, length times width, is 4 times 5, which just so happens to be 20 again. So we know that there's different multiples that we can use, or sorry, different factors that we can use to get us to 20. 1 times 20 works. 4 times 5 works. Right, so we haven't changed the area, but we did change the perimeter quite a bit. We went from 42 centimeters all the way down to 18. So to say that the rectangle that has the greatest perimeter has the greatest area, well, this had the greatest perimeter, but the areas were exactly the same. So this is not true either. Neither one of those statements is true. And I think I said in another video somewhere that the more you get your shape to be a square, right? This shape is a bit more square than what I had going on up there. And anything that is more square-ish that is going to have a smaller perimeter and a larger area. So what that means is if you need to buy material to build a dog kennel and you have 42 meters of fence that you can use, you could make a 1 by 20 dog kennel and the dog would have lots of room to run back and forth. So if you had like a very active dog that needed room to play fetch, that might be the way to go. If you had a big dog and he just needed to lay around and he needed a swimming pool and he needed one of them igloo things in the corner and he needed a, I don't know, dog spa over here, you would need a larger area, but you can do it with a lot less fence. So if you want to use your 42 meters of fence, you could have 10, 11, 10, and 11. You could give him a much bigger space than what you were getting over here with the 1 and 20. So you can kind of massage your perimeter a little bit and decide what's best for your application. All right, go feed the dog. Oh, I should draw him in there. Yes. My drawing is just getting so good, you guys. 4 legs, tail, happy face. Yay, and his tail is wagging.